So whenever you're looking to arrange something in a word, you do the factorial with number of letters. So say, for example, you have the word um, birthday. Okay, because I'm looking at the balloon here. It says birthday. Birthday obviously has 8 letters. I don't think any of them are repeated. No. So you say factorial. But if some letters are repeated, you're going to have some redundancy or some arrangements that are just the same. So in order to get rid of that, you got to see which ones are repeated, how many times they're repeated, and do a factorial of that on the bottom. You just work it out. I mean, it's a pretty big number. That'd be 8, by the way, 2 times 2 times 2. And then you multiply that out, wherever that is. It's gonna be a crazy big number. And I assume you have a calculator, right?
Yeah.
What kind of calculator do you have?
I think it's just a normal one that we're using for this,
Scientific or graphic?
like a scientific calculator, I think.
This should work, yeah. By the way, they should have the factorial button somewhere in there, or the NCR, NPR, but yeah, it's 453,600 ways you can arrange that. So pretty straightforward for that one. Okay. The sandwich consists of bread, meat, and vegetable. There are 3 breads, 4 meats, 6 vegetables. How many different sandwich choices are made? So it's the same thing, actually, if you think about it. So really, the whole essence here is called the multiplication counting principle.
Mm-hmm.
You count all the ways. Each thing could happen. So of all the breads, you only pick one of them. You do a combination, you can do 3C1, because NCR, the formula looks like this. It's n factorial over n minus r factorial times r factorial. So in this case, it'll be 3 factorial over 3 minus 1, which is 2 factorial. So you just get 3 ways that could happen. Or if you're thinking about it, you only pick one bread out of 3. So it's only 3 ways that could happen. For meats, you only pick one meat. You have 4 meats to choose from, so that's 4 ways. And vegetables, 6 ways. So really, you're just doing this. 3 times 4 times 6. So 72 possible sandwiches you can do. And so let's try one thing here real fast. Yeah, okay. So that's what you're doing for that one. With 70 objects, how many arrangements are there in a line, in a circle, and a bracelet? Okay. Well, so let's say this person's first in line, this
Mm-hmm.
person's last in line. So that's just 7 factorial. Now, a circle, that one's a little tricky. Mm. You put 7 people here. Um, but I think you can reverse it too. I don't know. Can you reverse it? So this is 5,040 ways for a line. Let me look that really fast. Mm,
I'm pretty sure for like a circle, they do
yeah, I
like
think it's just
n
yeah, it's just
minus
six
one.
factorial. Yeah, exactly. Yeah, yeah, because I guess then you're kind of stuck in that position there. So, um, this looks up really fast. I'm just kind of curious. Yeah, okay. So these are in 20 ways. And a bracelet, I think would be the same thing. Or actually, you could reverse. I think it might be 5,007 factorial 2 times. Oh, that's interesting. Okay, so it's like the circle, but if it's rotated around, it's still the same thing. Okay, that's kind of weird. So I think I'll overthink that one.
Mm-hmm.
Okay, let's keep moving. Um, if 2 dice are tossed, what's the probability that the sum is 6 or an 8? Well, that's 36 possibilities. To get a 6, there's 6 ways it could happen. To get an 8, no, so 5 ways it could happen for a 6, and 5 ways for an 8. So 10 out of 36, or 5 out of 18. Um, if any 3 kids once required each day to do a certain 5 p.m. chore, how many can parents assign to a chore in the course of a week? Well, I mean, you got to pick, you have 3 choices every day and 7 days in a week. So it'd be 3 to the 7th power, which would be 2087 ways. I mean, could be that you just pick the same kid all 7 days where that could happen. But you have three choices every day. And you multiply by seven. So it's like multiplication counting principle. Like there's seven slots, three choices for each slot. Fifth, the first letter cannot be a vowel. The last one cannot be a consonant. Okay. So you have three vowels right now. So obviously, so two vowels right now. So we only have three options here. And the last one cannot be a consonant. So you have two options here. And then clear three letters left after that. So again, multiplication counting principle, just count the number of ways each item could happen and multiply it out. That should be 36 ways. Questions so far? No questions?
No.
Okay. Okay, two cards taken from deck cards. First card goes to probably the second card. Yeah, we assume there's no replacement. Um, how many queens in deck cards?
Like 4.
So 4 out of 52. And then there's four threes. We have 51 cards left. Yeah, that. Okay. Cards number 1 through 9 are in a yellow bag. And again, a blue bag. Cards drawn from each. What's the probability that both cards are odd numbers? We'll find the odds. Okay. Okay. So you have five odd numbers in each. So it's 5 nines times 5 nines, which is 25 out of 81. But also both cards are the same number. Um, well, you do 1 1, 2 2, 3 3, 4 4, 5 5, 6 6, 7 7, 8 8, 9 9. That's nine possibilities out of 81. But since I want the odds, it means nine are in favor of that, 72 are against. So the odds of that happening are 1 to 8. Because for every 9 options, one of them's okay, eight's not. So the odds are 1 to 8. So not good odds, obviously, right? um, that's how odds are done. So it's always what you want to what you don't want, not by the total. That's probability. Seven whites, three reds, pick three. How many of these picks could have three whites or two whites and a red? So you have 10 cards total or 10 whatever, whatever these things are, like coins or tokens. So 10C3 is always 3 out of 10. If you want 10 whites, you do 7C3. Or if you're going to do two whites and a red, 7C2 times 3C1 Let's work that out. Yeah. So those are your probabilities right there. Okay, we're halfway through. It's good timing. See, 3 cards are picked from a deck. Was it probably that 2 will be face cards, 1 is a 10.
Mm-hmm.
So we have 12 face cards, Jack, Queen, King. So it's 12C2. You have 4 10s. So 4C1. It comes out to a pretty nasty number. Or 66. Or 55-25. That's good.
Mm-hmm.
Yep. 3 coins are in a die are thrown. Was probably getting 2 tails. And a prime number. A prime number has to have exactly 2 factors, so 1 does not count. But 2, 3, 5 do count. So it's 1/2 probably getting a prime number. Getting 2 tails. Well, if you flip a coin 3 times, or flip 3 coins, there's 3 ways you can get 2 tails. You go tail, tail, heads, tail, head, tails, or head, tail, tails. You should get 3/16. I mean, 4 card hands can be chosen from a 74 card deck. Well, oh geez. Well, the 74C4, I think. That's all you have to do for that one. So that's 1,150,626. The digits are randomly arranged randomly. Let's put that they're arranged in either ascending or descending order. Ooh. Actually, there's only 2 ways it could happen. So 1, 2, 1, 2, sorry, 0, 1, 2, 3, 7, or 7, 3, 2, 1, right? 0.
Mm-hmm.
Yeah, let's look at that again. So 0, 1, 2, 3, 7, or 7, 3, 2, 1, 0. So it's 2 ways. And then if you're arranging 5 numbers, that's 5 factorial. So 2 out of 120 or 1 out of 60. Again, probably is what you want about what's total. Select 3 cards from a deck. Find the that they're all black or all face cards. So the word or and matter a lot because and means it has to be simultaneous or just the one or the other. So probably all black. It's like 3 cards. Okay. So you're gonna be adding these 2 probabilities. So first of all, it's 26 black cards. So you do just like that. I mean, you could also say 26 out of 52 times 25 out of 51 times 24 out of 50. I mean, that could work. Yeah, and they'll be the same thing if you work that out. Yeah, it actually reduces very nicely. That should be 2 out of 17. But that's not done. We're not done yet. That's just for black. Got all face cards. You kind of do the same thing. Yeah, so it's kind of hard to add that. We have 2 over 17 plus 11 out of 630.
Mm-hmm.
Add that 2 out of 17. Yeah, it should be 791. I mean, you work it all out. 791 out of 66630. Or basically 0.119. Will your teacher have you do decimals? Would that be okay? Or
Yeah, I think so.
yeah. Yeah, so because you have to add it. That's so you gotta make sure add is 4. Because one or the other. And it has to happen both at the same time. Let's get 2 5s. So there's 4 5, so 4C2 times 4C1. True. Yeah. Because that's all one situation. So you have multiple, so that's still multiplication kind of principle. That's 24 up top. Yeah, it reduces to yeah, so 132,600. Yeah, so to get prime is 1/2 in it again. So 1/2 times 1/2, that's 1/4. The red die is 5, the blue die is more than 2. So 1/6 to get red, 5 on the red die. More than 2, that's 3, 4, 5, 6 is 2/3. That's 1/9. You have 13 numbers. So obviously, there's more odds than evens. So if 13 over 7 are odds. Sorry, 7 are evens. 6 are odds. So 7 to 6 are the odds there. For 17. Yeah, this is expected value because we saw quite a bit in the last one because we don't see too many. So this is good. We're gonna totally get this done. Kind of forgot some of the other answers already, but um, these answers all seem fine, I think.
Mhm.
Um, Okay. So anyhow, but you've seen the process, which matters, right? So
Mm-hmm.
pick a card from deck. If you get to seven, you win $20. As a club, you win that. Ace, you win that. So blackjack, you win. Blackjack is a 10 with ace, jack with ace, king with ace, or queen with, or sorry, queen with ace, king with ace. Want to make it a fair game. So the probability that you get a seven, that's 1/13th. A club, but you have to be careful because the club does count because you can get seven of clubs. Oh, a blackjack. I started thinking of blackjack. Sorry. Um, Still though, there's some overlap. And ace is also 1/13th. There's two jacks are black. Long club. 1/4 chance to pick a club. I'm not sure it's gonna be right. We'll check it out. I don't think this is gonna be the right way to do it. Ace is a 1/13th, and a blackjack that's one out of that's two out of it's one out of 26. Let's see. I don't know if that's gonna work. Yeah, I'm off a little bit. So I have $9.73. So you have to shoot, yeah. So let's think about it. So let's look at the sevens are not clubs. So it's 3 out of 52 times 20. Let's say you get seven of clubs. That's 1 out of 52 times $22.
Mm-hmm.
Let's say you get an ace. It's not a club. 3 out of 52 times 50. But that would be 1 out of 52 times $52 if you get an ace of clubs. You get a jack. Now, jack clubs are black. So you get a jack of spades, 1 out of 52 times 100. But jack of clubs, 1 out of 52 times $102. Then all the other clubs, the 10 other clubs you can get, and that's $2. I think that's what we have to do. Plus 22 out of 52, plus 50 out of 52 is 1. Ah, still got 973. Hold on. Mm, Huh, got the same thing still. 13 out of 52. Hmm, I think here. Um, yeah, I wonder if the teacher got the answer wrong. You had 2 put 9.62. I got 9.73. Well, I'm not sure what's going on. Good. I'm just gonna go with this. We didn't have to do all that work actually, because we just done the probably getting a seven club. I mean, I know some overlap, but let me think about this one more time. So if you look at seven in clubs, The Gallic is probably separately though. I was not gonna worry about it. You toss coin twice, two heads wins $8, two tails wins nothing. What should you win for getting exactly? This is assuming a fair game. Or well actually just that's expected value. So two heads, there's a 3/8 chance of that happening. Two tails, there's also 3/8 of that happening. So if I ask, what should you win for getting exactly one tail? That's a 3/8 also chance of that happening. We'll say times x equals 3. Is 2.25. Yeah, I should get 6. What? What am I doing wrong? Oh, he tossed it twice. Oh, I read that wrong. Okay. Yikes. That's a 1/4 chance times 8 plus a 1/4 chance times 0. Okay. That's a, you get one tail, it's 1/2. Yeah, it's also a 1/4 chance. So 1/4 x. So 2 plus that, so 1/4 x. That's one tail. Oh, it's 1/2 chance, my bad. So x has to be 2. Yeah, that makes sense. Okay. So that pretty much covers everything to get ready for test. And when are you taking the SAT again?
May 3rd.
Maybe they're okay. So let's aim to meet again later on to kind of talk about that. And let's see here. Do you happen to be free? Trying to think here. I want you to do some work too. Can you potentially meet actually for a second. Actually, I think we should aim to meet later this week. Are you free on Wednesday night?
I think so.
Okay, would 8 o'clock work?
Yeah.
Okay, well, let's aim to do that. I won't have you do any work. I just want to kind of just do some practice with you.
Uh-huh.
Um, and then I'll probably have you do a practice over the weekend, and we can talk about that afterwards. Because then now do you know when your spring break is at Wisconsin High School?
I think it's April 7th.
Okay, so it's coming pretty soon.
Yeah.
Yeah, because and the reason why I'm kind of adamant about meeting later this week is that I'm gonna actually be gone for a retreat from the 2nd to the 4th. So I'm not gonna be able to do any tutoring during that time frame. So yeah, I
Mhm.
think it's good to kind of squeeze in one if we can this Wednesday. So yeah, cool. I'll see you this Wednesday at 8 p.m. I'll send the invite right now.
Uh-huh. Thank
Okay,
you.
have a good one. Goodbye.
You too.
هذه اللي أعطاك إياها ما حطهاش في صحن في البول سخنة سخنة ولا باردة؟ باردة ولا سخنة؟ هذا نصب لك في قلب العلبة مش عنده صحن شحون مش عنده صحون ضل أخذت ضل أخذت عبيت الصحيح تشربهم باردة بدون وزي عارفين الحلاوة زي الزلمة الثاني الاثنين وبالي حاضر الكلام ولا بحكيش عنه قلت له بكره الساعة 2 يعني جاي بس معناته بتحكي معاه هناك وانتم هناك عشان انتوا والمرة تخلصوا التونس لا محامي ولا أسود لا محامي ولا أسود يا هذا النقطة بس مين عم بيطلع في الورق انت بقول اللاند لورد حلقة وبدأت عم في اللاند لورد تبع الزلمة هذا ترى قديش الريتس قديش ضايل الريتس تعرف النيو ريتس معناها إذا في عليها ريتس إنه كل الشارع أكثر يعني الله كله لما جيت عملت تعرفوا الشارع لا طبعا ولا هيك مشهور أكيد الناس تمشي فيه